Hello, everyone. Thank you for joining us today. My name is Megan Balding, and I'm pleased to be joined today by two of our faculty members from our Computer Science and Informatics programs, Professor Shahabi and Professor Knobloch, who will be speaking to our master's level programs today in our Discover Viterbi webinar. So before we get started on the presentation itself, I just want to go over a couple quick housekeeping items. The first is that we will be sending out a copy of the slides after today's presentation. So there is a lot of really great information in the presentation today. So those of you attending the live session will be getting an email with a PDF of these slides. For those of you that may be joining us after the fact and reviewing a recording of this session, we will be providing contact information at the end of the session today where you can email us for additional questions, and we can also provide you with a PDF at that time if you so desire. Additionally, for those of you attending the live session today, we will have time for question and answer. So I encourage you to use the Q&A panel to ask any questions that you may have of the faculty members that are joining us today based on the programs that they'll be presenting. So the format of today's presentation will be a quick overview of USC and the Viterbi School of Engineering. That will go through very quickly, and then I'll be passing the presentation over to our faculty members who will be specifically discussing our programs in computer science and informatics data science at the master's level. We'll be having time after each of their sections for question and answer, so I encourage you to send over any of those questions throughout the presentation so that we make sure we address those directly. So please do, again, use the Q&A for that. I'll then go over briefly Dept Viterbi, which is our online delivery method and how that works, an overview of our tuition and fee structure, and then we'll have some additional time at the end of the session for Q&A again. Oops, sorry. If you are not familiar with the University of Southern California, we provided some images of our campus here. We are the oldest private university in the Western United States, founded in 1880. We have just over 47,000 students, about 20,000 undergraduates and 27,500 graduate students. We have just over 4,400 full-time faculty members and a diverse student population with students from over 100 countries in all 50 states. The campus itself is located in Los Angeles. We are located right near downtown Los Angeles, so lots of access to the industry and exciting things that are happening in the LA area. In terms of the Viterbi School of Engineering, we have 8 academic departments, 185 tenure-track faculty, of whom over 20 are members of the National Academy of Engineering. Over 60 have received the NSF Career, National, and Presidential Young Investigator Awards. Our alumni, or the Trojan Family Network as we call them, are over 77,000 strong within the School of Engineering. So we have over 77,000 engineering alumni located throughout the world. Our current student population is just over 2,700 undergraduate students and almost 6,000 graduate students, 5,922 to be exact. In terms of the research, we won't be going into that too much today. I encourage you to visit our main school website, viterbischool.usc.edu, as well as the individual departments. Each department has their own website. That goes into a lot of the exciting research and the research centers that are located here at the Viterbi School and can provide you with more information, including overviews of the 35 research centers and what we have going on with the more than $207 million being spent in research expenditures annually. U.S. News & World Report consistently ranks us the top graduate engineering program. We are currently one of the top 10 graduate engineering programs overall. In terms of our online graduate engineering programs, we are currently the #1 and have been consistently ranked the #1 online computer science, graduate computer science program. And we are currently the #2 online graduate engineering program over all 40 programs that we do offer. U.S. News & World Report also provides a ranking as it relates directly to veterans, so we included that information as well. In terms of individual points of distinction for the Viterbi School of Engineering, we have a strong international reputation for excellence. A lot of that has to do with some of the exciting research that we have going on here within the Viterbi School directly. I mentioned our Trojan Family Network. That's over 77,000 engineers strong. We have programs that are available on-site, on campus, and online at the doctoral, master's, and bachelor's level. At the master's level, those programs are available online and on campus. At the bachelor's and doctoral levels, those are our traditional on-campus programs. We do have continuing education offerings as well that are available online, on-site at companies, as well as traditional on-campus programs. In terms of this Viterbi School of Engineering, again, we are consistently considered a leader in funded research within the United States. We have highly interdisciplinary research environments, diverse research areas that include robotics, software engineering, sensor networks, vision sciences, automated construction, and photonics. Again, this is a quick overview of a lot of the research that's going on here at the Viterbi School, so I encourage you to visit our website for a greater overview of these areas. One of our strengths is our industrial partnerships and collaborations. Being located here in Los Angeles, we have direct access to many of the industry leaders in a lot of different fields. Additionally, we have a lot of collaborations with other academic institutions throughout the world. So that was my quick introduction, and I don't want to spend any more time focused on that. I'd like to give most of the time we have here today to our faculty members, providing them with the opportunity to share information on their programs. So the first presenter will be Professor Cyrus Shahabi. He is the chair of the Computer Science Department. He is also the director of the USC Integrated Media Systems Center. He is also a professor of computer science, electrical engineering, and systems and spatial sciences. The next presenter following Professor Shahabi will be Professor Craig Knobloch. He will be speaking to our informatics and data science programs. He is the director of Information Sciences Institute. He's also the director of our informatics program, and a research professor of computer science and spatial sciences. So without further ado, Professor Shahabi, I'll leave that presentation to you.
Hi, this is Cyrus Shahabi. I start by just telling you this is a very exciting time for the field of computer science. So if you're interested to continue in this field, I think this is perfect timing. I put just two bullets there, mainly describing two facts as a evidence for how exciting it is to be in computer science. One is that if you basically listen to any mainstream media, you start hearing these very specific research areas within computer science that like 10 years ago nobody knew what they were, but now you hear them in the news. Things like machine learning, robotics, privacy, cybersecurity, and big data, and so on. And the other point I want to make is that some of the major companies with societal impacts, even though in the surface they may not look like a computer science company, like for example Lyft or Uber, they may look like a transportation company, or Amazon may look like a company providing products and selling products, but underneath they're really just computer science programs, and they're hiring in this field significantly. So it's a very good timing for being interested in this field. At USC, we have several Master of Science programs in computer science. Here is a list. The first one is our main computer science master program, and then we have some others that I'll later on show you how many students end up in each one of these programs. Our general Master of Science in Computer Science it basically has 28 units. There's a core curriculum that basically consists of 4 units of a required course or analysis of algorithm. Many companies are interested in this. That's why we have this as one of the required courses. And then there are 3 other courses that you can choose 2 of the 3. We're actually in the process of changing this, but for now, this is basically our AI course, the web technology course, and a database system course. And then on top of these, there are another 16 units that can be electives from various courses that we offer. There's one other master program that I want to emphasize a little bit more, and this one is called Master of Science in Computer Science for Scientists and Engineers. This is really a master program designed for students who do have a background in engineering or science, but not necessarily a background in computer science. That's why there are some prerequisite courses that they need to take. As a result, instead of 28 units, this master program has 37 units, and it includes a 4 units programming course, again assuming that the students don't have a computer science background, and then 2 additional courses as added here. One is our operating system course, which is a 400 level course usually offered to our undergrads, and then one of the 3 courses in computer networks, or sorry, 2 courses of computer networks or computer system organizations. Then these are electrical engineering courses basically offered. Other than that, the rest pretty much looks similar to our general master program. Still, you need to take the algorithm course, the AI course, web technology course, and database course. And now, because of all these, you have less number of elective courses. I want to give you some statistics about our department. First, basically show you the number of students in each one of our master programs that I mentioned. As you see, the majority end up in our general master program. Currently, we have about 1,300 students there. After that, the next most popular one is actually the one that I just mentioned, the computer science for engineers and scientists. We have about 500 students there. And the third program that is very popular is our data science course. That put us almost up to 2,400 students currently in our program. There are some statistics about our informatics program that Craig, I believe, will talk about that later on. Just to give you a quick view about our faculty, we have about 45 tenure track faculty in our department. Currently 19 teaching faculty and about 35 research faculty. And these are all growing as we speak. We are hiring both in teaching and tenure track, and then research faculty we continuously adding. Our department has an advisory board or a leadership team, depending how you want to call it. It includes myself as the chair, but we also have 3 associate chairs that you see the names there, one for PhD program, one for undergrad, and one for master program. So Professor Ellis Horowitz is the associate chair for a master program. We also have 4 main areas of research and teaching, basically, that are listed there, and we have 4 area leaders for each one of those areas. The 3 pillars of our CS, classroom interaction, peer interaction, and research. Here is some bullets I want to basically present to you guys as the unique features of our computer science department at USC. There are a lot of research opportunities, including capstone courses that you can actually, in our master program, the general master program, there's a thesis track that you can take, and that would be more research-oriented. You can join research labs and work with the faculty on their research. There's a very active USC Alumni network. They are at top companies, multidisciplinary research, so it's not just within the School of Engineering, but across our schools in communication, journalism, medical school, policy, business, and cinema. Several programs, if you're interested in startups, these programs provide sometimes seed funding, sometimes actually some training, put you in contact with business school students to help with business plan writing, as well as sometimes with entrepreneurs who can be the mentors. And of course, we are at the center of IT, game, and entertainment because of both Silicon Beach and the Hollywood proximity. So now I give you some evidences of what those bullets that I mentioned before. The hands-on experience, I want to emphasize that our USC Trojan team continuously win in the regional Olympics. This is the result from the latest one. As you see, USC Trojans are first, winning the UCLA, the Caltech, as well as the Harvey Mudd teams. And this is not just this year. This has been the case for the past several years. This is actually the 6th time in 8 years that USC advances to the World Final. USC team actually was the only team that solved 10. Actually, there's a column missing. The 11th column is also there. So there are 11 questions, and 10 of which was basically solved by the USC team and the USC Trojans team. And USC Trojans team was the only team that solved all 10 of the 11 problems. Research-wise, just talking from my personal experience, I usually have 4 or 5 master's students working in my lab. This is the list of the most recent one graduated, and as you see, they all ended up at top computer science companies such as Amazon, Microsoft, and IBM. Here is a picture from my lab students in 2005. It includes several master students. I don't have a pointer, so I can't point on them. But one of them, Farnos, for example, who was a master student, graduated from my lab, now is the director of engineering at Snapchat. Another one of my students started his own company. There's also a little bit of an email that I received last week, actually, about one of our courses. I think this was the web technology course that the student basically said he or she, I forgot, was very lucky to be in the course and learn about the iOS app and how that helped with the recruiting. I also want to mention this article that shows that after Berkeley, Stanford, and CMU, USC is basically ranked 4th in the most alumni that go to the Silicon Valley. Two new initiatives at CS. One is the Informatics program, CS for All, and I think Craig will talk about that in details. The other one is the CS Industry Affiliate program that we started. It's basically a program to bring the industry closer to the with the department, not just with the students, but also with the faculty and research. It started in July 1st, 2018. And currently, we have these companies join as members. We have these founding platinum members, including Google, Lyft, Microsoft, and so on. This is a very exciting program. We had a career fair as a kickoff on September 12, 2018, and a lot of students show up. Actually, 600 students showed up, and they discussed with our affiliate companies. They exchange resumes and so on. And then here is just a list of some other industry affiliate program events that we had so far. Actually, we had more, but this is the one that I had when I was putting the slides together, showing various events by various companies. And at this point, I think I will open perhaps for questions for the computer science before Craig continue with the Informatics program.
Perfect. So one of the questions we have is if this individual is coming in with a bachelor's degree in engineering, not in computer science, but has been working within the field of computer science for some time, can they apply to the general Master of Science in Computer Science, or would you recommend applying to scientists and engineers?
My recommendation is scientists and engineers, again, because they might be able to waive the programming course if they actually had a programming background, but not necessarily having our operating system and or system organization courses. I'm sure Craig also will talk about some other opportunities within the informatics program that they can apply as well.
Great. So just to encourage everyone attending the live session right now, if you do have any questions, please do send those over to the Q&A. Another question here is the student is interested in doing the program online and is wondering if the thesis option is something that they can pursue as an online student.
Well, that's a good question. I haven't thought about that. The main requirement for the thesis option is that you find a faculty to work with. So if they can convince a faculty that by email and Skype you can basically do the thesis, I think that's acceptable to the department. It's really the faculty, between the faculty and the student. And the faculty basically, there are 4 units of thesis, two units. So they need to take 2 units one semester and 2 units another semester, during which they work with the faculty. They need to do an oral presentation of their thesis. For that, they might need to actually be on campus because there's a committee of 3 or 5. I'm not 100% sure. I think it's 3 that they need to present the work to them. So at least for that, they might need to be present on campus.
Great. Another question here on the scientists and engineers track, and it's for someone that is coming from a bachelor's degree in biology, so not in the engineering field at all. Do you see students coming in with a science background, and if so, are there any preparatory courses that they should be taking prior to applying?
Science courses are okay. So as it was mentioned on the slide, both science and engineering is fine. They might have a little bit of a disadvantage when it comes to some of the courses that require more solid math background, probably as compared to the engineering students. So if they can study statistics, linear algebra, calculus before applying or before coming to the program, I think that would help. And again, there are other opportunities in informatics program that might be more appropriate for somebody with a science background.
Thank you for answering her question. So another question is, if someone is looking at some of the specializations in computer science and deciding between going down one of those routes versus just a general program in computer science, what is your advice to them in terms of what they should be looking at as they compare programs?
So one point is that the general computer science, it's 28 units, but these specialized ones, usually there are 32 units, so they should be prepared to take an extra course. Our courses are 4 units. Now, what they want to compare is really based on what their interest is. I mean, like, for example, our computer game program is very popular. And these are the students, basically, that would need to take some courses from cinema school. So if they are okay with taking courses, for example, more in not necessarily just computer science courses, but cinema school courses. So each one of those, actually, they can go on the web, and the detailed curriculum is on the web. So I suggest that they look at those and they see what sort of courses or extra courses, required courses are needed, and whether those are the type of courses that they think they can handle. I think in that case, and then, of course, their own basically desire of what type of a degree they would like to get and what kind of a job and career they want to have afterwards.
Great. So this question here, I think you'll probably defer to Professor Noblock, but I'll ask it. And then, so this individual says, I did my undergraduate degree in a non-technical field business, but I'm comfortable with mathematical concepts and programming. Would I be able to apply to the computer science program? And what are my options?
Again, yes. I mean, the sciences and engineering program, definitely that's doable. Again, I assume with the business background, they have a background in math, enough math background to handle our courses. But again, the informatics program also has several, actually, master programs that are specifically designed for non-computer science background.
Okay. We'll probably be asking some of the last question here. If anyone else has an additional question on the computer science options, if you want to send those over now, we'll make sure we get to them. The next question here is about research opportunities. So you mentioned research, individuals that have completed research as master's students in your lab, and that there's cornerstone options and things like that throughout their program, or capstone, I'm sorry. Is there, in your experience, what are most master's students doing in order to gain research experience while they're here at USC?
So there are two basically orthogonal ways of doing it. One is that we have this directed research units that any master's students can take directed research units. I think up to 6 units they can take, and these are basically, they need to, again, find a faculty member who's willing to work with them, and once that basically handshake is done, then the faculty would approve the directed research unit, and then the student would work with the faculty for whatever topic the faculty decide and they agree on. There's another option, which, again, it's orthogonal, we can do both, but it's just directly communicate with the faculty member and join their labs. There are sometimes some financial opportunities. So, for example, for my lab, sometimes if I see a master students with a good background that is very consistent and aligned with the research we are doing, we provide them with some hourly pay, and then they would get involved again with the research, with the faculty, and they can basically do both. They can take directed research unit and also work with the faculty member and get paid.
Perfect. So we'll make this the last question. The question is regarding video game design and development, and if you could just speak a little bit more about those opportunities within computer science at the master's level.
I mean, if that's of interest, I would highly recommend that they actually go to the game master program, not the general program, because the general program, first of all, it would be tough for those students to get into the game courses because the priority is for game students. And then the number of required courses and so on would limit them on the courses they can take in the game program. But if they are in the game program, there are a couple of courses. There are actually one capstone type courses that goes over 2 semesters, and during which they actually go through the whole process of designing a game. And in this course, they would work with other students with other backgrounds, like art or from cinema school, because developing a video game is not just the programming and the technical side, but it requires a kind of a producer-director type of a person, as well as an art person to help with the design of the video game. So, and we have, I mean, our game program has been very successful. We just recently had an MOU with our cinema school that was actually in the news. So that, I would say, is the right approach.
Perfect. Great. Well, Professor Shahabi, thank you so much for sharing information about computer science and our options for master's programs. At this point in time,
thank you.
Thank you. At this point in time, Professor Novak, if you wouldn't mind speaking to our master's programs in informatics and the options that our students, applicants may have in those areas, that would be great.
Okay. Yeah, I'm happy to do so. Thank you. Okay, so I'm going to talk about the master's programs that we have in informatics, which is also in the process of getting renamed to the master's program in data science. So we have 8 programs overall. 2 of the programs are offered on DEN. One is the Applied Data Science program that's starting in the fall. That will be offered on DEN. And the second program that's also offered on DEN is the Cybersecurity Engineering program. And I think Megan at the end is going to talk a little more about how DEN works. In addition, we've had a program called Master of Science in Data Informatics. And this slide's wrong. It's actually being merged in fall of 2020. It's actually getting merged into the Applied Data Science program. And I'll talk more about that in my slides and explain how the Applied Data Science program is actually changing to sort of accommodate that. But you can sort of view those as sort of the 2 general sort of data science degrees that we currently have. Then we have a bunch more specialized degrees, you know, the communication data science, healthcare data science, spatial data science, public policy data science. These are all interdisciplinary degrees, and I'll talk more about how those work. And then finally, we have a certificate program called Big Data Fundamentals. And I'll talk on that one at the very end. So just to give you a sense of, you know, the current size of these programs. So these programs are all smaller than the computer science one. We have, but there's a lot of overlap, and I'll talk, you know, when I get into the individual degrees, I'll talk about them. But you can see that, so currently in the Applied Data Science program, we have about 53 students. Data Informatics program, 197 students. But those things are really getting merged so that, you know, that will become the biggest program, the Applied Data Science one. The Cybersecurity Engineering program would come next, and that's one that really focuses on exactly what it says. And I'll talk more about that as we go. And then these interdisciplinary programs, the Spatial, Communication, Healthcare, and Public Policy. And you can see the numbers of those range. The Healthcare Data Science, Public Policy Data Science are both relatively new programs. I don't actually know the number for the Public Policy one. I'll have to get that. And the Healthcare Data Science is just being launched. And there's just 1 student in that program now. But I expect there'll be quite a few more. So we expect that program to be very popular. Okay, so now let me talk about, I'm going to go through each of these programs just briefly and give you a sense for what each of them involves, so you have an idea of whether or not it might be relevant to you. So the first one is sort of our general data science degree, right? So this is applied data science. The goal of this program is to provide students with a basic understanding in terms of how to use these what are called large data environments, sometimes big data. This includes things like Hadoop, HDFS, Spark. You may have heard of some of these different kinds of tools and stuff, but all this cloud infrastructure that people are already talking about, that's really key here. And the second thing is to combine those with the various kinds of analytic tools, right? So many of you have probably heard a lot about machine learning lately. So we have classes, machine learning, data mining, visualization, user interfaces, and so on. And then the goal is to then be able to learn these methods and apply them to real-world problems. And to try to make this concrete, I put an example on this slide. This is some work I did with a colleague a while back, where it's a nice example of how to combining the big data with the analysis stuff. Okay, in this example, what we did was we actually gathered data from online sources looking at the cost of different flights. And this graph you see here is basically the graph of a particular flight between two cities over time. And you can see that these prices change dramatically over time, right? Starts at around 500, then drops down to around 300, and then shoots back up and then goes up and down. And we discovered that, you know, there was a tremendous amount of variation in sort of flight prices. And we wondered whether or not we could actually look at, sort of basically mine the historical data and then predict prices in the future. And we were actually, and to do that, right, you need both the infrastructure to process all this data at scale and combine that with machine learning techniques or data mining techniques, so then you could do these kinds of predictions. And so on the very right side of the slide, what it shows is actually on the Microsoft Bing page, where it used to actually have this feature. You may see where it says to buy, or it sometimes could say to wait. And essentially, Microsoft was actually licensed a patent on this work and used it on their website. It's no longer on their website because Google actually purchased the company that was providing the data. But you'll still find it on the Kayak page. So if you go to Kayak, you'll still find that feature to buy or to wait. And that basically comes from this kind of analysis, where you're combining the machine learning techniques with sort of this analysis of sort of data at scale. Okay, so that's just an example of sort of the kinds of, you know, problems that you could solve learning these kinds of techniques. Now let me talk a little bit more about the curriculum for this particular degree. So this is a 32-unit degree, similar to all the specialized degrees in computer science. It's designed for students with a range of backgrounds, right? So you might start out in this program and you have no programming experience. That's okay, but you'd assume to have a strong math and science background. Or it might be that you're actually a computer science undergraduate major and you already have a lot of computer science under your belt, but you want to get more into the data science field. And so we've really designed this degree program to be flexible to handle this range of students. And so the basic set of required courses are ones that we will require every student to take, which is basically the foundations of data management, which is, you know, how you use all these big data or large data infrastructure. Machine learning, and then data mining, right? So those are the three courses that everyone in this degree program takes. Now, if you come in and you don't have much computer science background, then we essentially push you into a track where we say, okay, we really would like you to take this sort of initial sequence of classes, which consists of basically underlying sort of programming for informatics or data science. And this is a course where you learn how to program in Python, which is used throughout the rest of the courses. You know, many of the courses will have programming assignments and homeworks and so on. The second class is Introduction to Computational Thinking in Data Science, and this is one that really is intended to sort of bring you up to speed on all the different kinds of techniques and data and various things that you'll actually be working with throughout the rest of the degree program. And then finally, there's sort of an intro class, this overview of data informatics and large data environments, which is intended to give you sort of a more gentle introduction to sort of the big data infrastructure, to the machine learning techniques, the data mining techniques, before you get into the more specialized classes. And when you might be then taking those other more advanced classes with other students who have more CS. And but we really designed this degree program so that if you don't have a bunch of computer science courses in the past, that you can actually start this program and then you take this initial sequence and then get into the more interesting courses. The next slide, what I have here is, now these are the other part of this degree, right? So it's a 32-unit degree, 12 units are required. You can take those next three classes if you don't have any computer science background as electives. They count as these electives. Or you can take all these other classes. And so we have quite a few choices here. You see there's both informatics classes here as well as computer science classes. And I won't go through the details of all these except to say that we have a variety of sort of really interesting, sort of more advanced topics. Information visualization. There's a class that I helped design on building knowledge graphs, INF 558, which is a nice sort of capstone class for students. There's the Data Informatics Professional Practicum, which also is a different kind of capstone class where you can build on all the things that you've learned. And then we have special topics classes, and these are often of interest to students, and you can look at the USC schedule to see which ones are offered in coming semesters. So for example, one we offered last semester was Probability and Statistics for Data Science, which is very popular, and we're in the process now of turning that into a regular class. So that will become, a course that's offered every year. In addition, you can draw on some of these computer science classes. So for example, maybe you want to get more into algorithms and take the analysis of algorithms class or the foundations of AI class. And so or applied natural language. Those are all very popular courses and would be, possible electives. So if you come in with a CS background, you would just take those 3 core courses, and then you basically can build your own curriculum based on your interests and which courses you're most excited about. Okay, so let me move on now and talk about some of the other degree programs. So the next one is the Master of Science in Cybersecurity Engineering. And, this is really a key area. I mean, you hear in the news over and over again about, the cybersecurity threat these days, and there's just a tremendous need for people in this area. And so this degree focuses on basically the fundamental sort of underlying theories and the practice in terms of, how you basically secure information systems, right? And it addresses a whole variety of challenges, including, policy formulation, how you build sort of verifiable secure operating systems, how you create security-aware applications, use of cryptography in these kinds of applications, how you build software for high-assurance environments. These are environments where you can really be confident that no one could actually break into your environment. And then finally, how do you create highly distributed cloud and network-based applications? And then, here's the courses. So this is also a 28-unit degree. There's 20 units of required classes, so that's basically there's 5 required courses here. And these are, one of them is the CS course, Security Systems, and then 4 informatics courses listed here. And then you have some flexibility. So you get to take one of the following on the right-hand side here, 521, 526, or 528. And then there's some additional coursework that you could take. So there's 4 to 5 units of additional coursework that you could take from a variety of choices in the CS department or other informatics classes. Let's see. Now let me talk about these interdisciplinary programs. And I just want to first sort of put this in context in terms of where these programs sit. So we have the computer science degrees, which Professor Shahabi already talked about. And so, data science is really a sub-discipline or a subarea within computer science, right? It talks about many of the techniques that, come out of the computer science field. And then, we have sort of specific areas of study, right? So you might have marketing or biology or, healthcare, any of a variety of areas of study where people specialize in those areas. And the goal of sort of these interdisciplinary programs is to kind of bring these things together, right? That you take the data science techniques and look at the combination of those with the specific areas of study. So that might be, mining social media for marketing, for example. And you can sort of see at the very bottom here, you have on the far left side of the slide, you have the computer science set of skills. On the far right, you have sort of the expertise area. And then, in the middle here, you have these sort of basic computer science kind of skills applied to these different kinds of expertise areas, right? So you may not, if you want to do one of these degrees, you may not go as deep into the computer science stuff, but the goal is to actually, train you in both so that you have the background so that you can actually apply these techniques to particular areas and stuff. So here's a slide that sort of shows now how this relates to our specific degree programs, right? So you can see here under the interdisciplinary data science thing, we have the Master's in Spatial Data Science, which was launched in 2015, the Master's in Communication Data Science, Master's of Public Policy Data Science, and Master's in Healthcare Data Science. And the idea is that these are joined with other parts of the university, right? So we don't just teach these in informatics. The idea is that you're actually taking courses in these other parts of the university. So for example, if you're in the communication data science, then you would also be taking courses from the Annenberg School of Communication and so on with the rest of them. And I'll talk about each of these individually now. Okay, so let me start with sort of the general sort of common requirements across all of these. So these are similar to the same, or no, they're the same as the sort of the core set of courses that we recommend for people that are coming in to apply data science that don't already have a strong background in computer science. And so there's these three initial courses: the Introduction to Computational Thinking in Data Science, Principle of Programming for Informatics, and Overview of Data Informatics in Large Data Environments. And so pretty much any of these interdisciplinary degree programs, you would start with these 3 courses. Now, it's important to note that, if you know computer science background, then you're going to basically be introduced in sort of the data science fundamentals. But if you do come in and want to do one of these interdisciplinary programs, that you can actually place out of these classes, right? So if it turns out that you already come in and you already know how to program in Python and you're quite adept at that, and maybe you've had a lot of computer science, we won't force people to take these 3 introductory classes. That you basically be able to place out of those classes and then replace them with other more advanced classes. So, for example, then maybe you would take INF 551, 552, and 553, which are the other sort of required classes for the applied data science. And so that really gives students sort of enough flexibility that based on their background, we want to make sure that you take the classes that are sort of going to be of most interest and relevance to you. Okay, let me talk just briefly about each of these 4 interdisciplinary degrees then. So we have first the Master of Science in Communication Data Science. And so this is really intended, this is joint, as I said, with the School of Communication. And the idea here is to teach you sort of the theories and principles of sort of human communication through technology, and then all these emerging platforms, all the social media stuff, collaboration tools, virtual reality, and look at how all of this is affecting sort of social dynamics and behavior through these different kinds of communication technology. And that's sort of on the communication side. And then you see the box here on the data science side. And these are the kinds of things that you would learn from the data science parts of the curriculum. So, computational thinking, how to program, how to deal with these large data systems, machine learning, privacy, visualization, and so on. The requirements for this one, this is another 32-unit program jointly with the School of Annenberg. And the curriculum for this one has 5 required classes. So 2 of these come from the communication side. The first 2 here are theoretical approaches to multidisciplinary design projects and innovation in the information economy. Those are the communication, which comes from the Annenberg side. And then the other 3 classes I already mentioned. In addition, there's another class from the Informatics core, right? So this is from the list of sort of approved classes that you can see online if you go to the web page for this. And then finally, from the communication core, there's 2 additional classes to take, and there's a specific set of approved classes for that. The Master of Science in Healthcare Data Science is really focused on, how can you actually manage and process data to improve healthcare, right? And there's a tremendous need and interest in this. This is really, data science for both clinical research and translational medicine, right, which are sort of 2 areas within the healthcare world. And it includes things like, personal devices and mobile apps to monitor healthcare, and looking at sort of data science techniques to basically improve health and healthcare delivery. Then, that's on the healthcare side, and on the data science side, it's the same as the communication program I just mentioned, right? But there's sort of a common set of courses and material that you learn on the data science. The degree itself, you can see, is 32 units. There's, again, 5 required classes, and you'll start to see a pattern here, right? There's a couple of classes here that are coming from on the healthcare side. Advanced topics in biomedical systems and topics in health, technology, engineering, and then the other 3 sort of core courses. Then the students then have some flexibility. There's 12 units, which would be 3 classes, where students can take 1 class from the data science side, 1 class from the healthcare side, and then the remaining class they can choose. Right? So basically, they have some flexibility there. The next one is the Master of Science in Spatial Data Science. This is really about all things spatial, right? So this is, there's all this work now on essentially on dealing with maps and imagery and all these different data sets. There's an image here shown on this slide of some analysis on top of the Earth here. And really, this is all about learning on the spatial side, spatial computing and what are called geographic information systems, which are systems designed for dealing with geographic data. It includes things like spatial decision support, geospatial problem solving. You learn all about spatial databases, which are a way of actually storing spatial data in a database, spatial modeling, spatial data analysis. And then on the data science side, again, it's the common set of techniques we've seen in these other programs. This is a 32-unit program as well. It's joint with the Viterbi School of Engineering and the Dornsife College of Letters, Arts, and Sciences. And so here again, you're going to end up, if you look at the required courses, in this case, there's 24 units required, 8 electives, and then you have the 3 sort of common data science classes. In addition, on the spatial sciences side, you have concepts of spatial thinking, spatial computing, and spatial analysis. And then you get to choose the other 2 classes from a approved list of electives. Then the last interdisciplinary program is the Master of Science in Public Policy Data Science, another relatively new program. This is joint with the Price School of Public Policy. And the goal of this is to basically improve government data analysis to do things important like increase accountability, improve performance, and increase quality of services. And deal with things like institutional legal challenges of collecting data from citizens, how we incorporate data science into government and public policy. That's on the public policy side. On the data science side, we have, again, the common set of data science classes. This is a 36-unit program, and, the required classes, it has 20 units of required courses. So there's 4 from public policy. These are the first 4 listed here. And then 3 more are sort of the common data science classes. Then there's 2 classes that are essentially your elective classes. And then finally, there's a capstone course for this degree program, which is joint between the data science and public policy. And then lastly, I did mention at the very beginning, we do have this graduate certificate in big data fundamentals. This is a 15-unit certificate program. And so a certificate means it's not a full master's degree. It's something you might do if, okay, you don't have the time to do, a complete program of 28 or 32 units. But rather you just want to get some basic fundamentals here. And so this includes the 3 sort of core courses I've mentioned several times, and then another more advanced class, INF 559, an Introduction to Data Management. And I think, now it's time to hand it back to Megan.
Thank you, Professor Knobloch. One question actually that just came up, and I want to make, just because it relates directly to your programs. The question is, this individual is specifically interested in the communication data informatics program, and their question is that they live in Los Angeles, but they do work full-time. Mm-hmm. Can they do the program? Is it possible to do that program here at USC while working?
That's a good question, because parts of that program will be available on DEN. So in fact, essentially the data science part of it would be available on DEN. And I think then the question would be to take a look at since they're here in Los Angeles, to take a look at the schedule for the communication program and the communication courses there, and look to see if they're offered at a time that they might be able to get to campus. Because I don't believe that the communication courses are on DEN. So they'd have to figure out a way to be able to take those classes. And either it may be that some of those classes are offered late in the day, early enough in the day that they could actually get to them. But I think the whole part of the data science side of it, which would be really half the programs they could do online, they'd still have to figure out how to take the other courses that are not online.
Great, thank you. And so just to note, to look up classes and their schedules, you can just Google USC's schedule of courses, and it'll pop up, and you can find out just to get an idea of when those courses would be offered. So I'll quickly go over some of the admission criteria and get a little bit of an overview of the distance or online program that we offer here at USC Viterbi, and then I will leave it up to question and answer at that point in time for any remaining questions that you may have, those of you attending today's session on any of our programs or just in general about the Viterbi School. So to quickly go over the admission criteria, this is the general admission criteria for all graduate programs at USC. So the most important thing to note of this entire slide is that each program has its own unique requirements. So we encourage you to visit the website to visit the individual program pages to find out the program requirements or admission requirements for your individual program of study, the one that you're interested in. Across the board, though, most of our degree programs do require an undergraduate degree in engineering, math, or hard science from a regionally accredited university. This is shown through your transcripts. We're generally looking for a cumulative GPA of at least a 3.0 on a 4.0 scale. This is recommended but not required. The GRE is going to be required for all programs and must be less than 5 years old. The CV, your CV or resume is also required as part of all applications, and then depending on the program of interest, they may also require supplemental letters of recommendation and a statement of purpose. If you are an international applicant, then the TOEFL would also be required. So a quick note on some of the coming application deadlines. For fall of 2019, the deadline was January 15th. If you are interested in DEN at Viterbi, then you do have the ability to still apply for fall of 2019. We do have an application extension available. You can email us for more information at the email address indicated at the bottom of the slide. We have also listed our upcoming spring 2020 and fall 2020 application deadlines. One quick note as it relates to some of the specific programs discussed today. The Master of Science in Cybersecurity Engineering is only available for fall application. So if you are interested in that program, please note that you'll be applying for either fall of 2019 if you are interested in the program, pursuing the program online. Otherwise, you can apply in fall of 2020 with a deadline of December 15th. So the other mention I wanted to also make is the Master of Science in Applied Data Science. That program is, as Professor Noblock mentioned, now available online via Viterbi. If you are interested in starting that program in fall of 2019, you can begin that program as a limited status student. So I'll be discussing the limited status enrollment option for fall of 2019 and how that works. Otherwise, we will have information in terms of getting started and applying in the future. You can email us at the email address provided, and we can provide you with an overview of how you can formally apply. So just in some general questions about alumni and where they're going on from programs. I think Professor Shahabi mentioned it related to some of the companies and that computer science graduates are able to move into. But where do you see our informatics graduates going once they've completed their program and the types of opportunities available to them?
Yeah, we see them going to a whole variety of places. I mean, they're certainly in demand now, so I don't think our students have any problem finding jobs. Some of the students go to the traditional places. Professor Shahabi mentioned some students have gone to Google, Amazon. They do a lot of hiring. Quite a few of them move to Silicon Valley, although there's been growing jobs and interest in Silicon Beach here in Los Angeles, and so quite a few of them get jobs there. Some of them go to small startup companies that are doing various sort of more specialized things, and then quite a few of them go to the big organizations. And I think one of the things that happens in many of our students is that when they come to USC, they typically go and do summer internships while they're doing here, and I see that as a common path, right? So usually I recommend that students apply to the places you want to work when you graduate, because oftentimes they go and work there for the summer, then they get an offer, and then go work there when they're done. All the big players, and then a whole variety of smaller companies as well. And so very similar to the ones that the students in the CS department would go to.
Great. So the next couple slides will just quickly go over our distance model, how that works, how you can pursue your program online. So we have 2 course delivery methods available for a number of our programs. Of course, all of our programs that we spoke about today, our master's and graduate certificate programs, are available on campus. The majority of our students pursuing the programs on campus are pursuing that as a full-time student, which means they're, as part of the computer science and informatics program, taking around 2 classes per semester. If it's a lower unit class, like a 3-unit class, then there's some flexibility there. But on average, our students are taking around 2 classes per semester as a full-time student. And it's taking them about 1.5 years to 2 years to complete the program if they're doing that full-time. In terms of our online delivery, most of our online students are taking around 1 class a semester. Some are able to take 2, but usually that's a little bit of a heavy load if you're working full-time. And that means they're completing the program at a little bit of a slower pace at around 2.5 to 3 years to complete their degree program. Viterbi is our online delivery method. It is a web-based delivery system that is unique to the Viterbi school. We do run our own delivery here. And it enables our students to access classes from around the world. They're able to do that live, on demand, or by download. The way our program works is it is integrated with the on-campus program, meaning you are pursuing the program, the same program as your on-campus counterparts. It's the same lectures that you're viewing as an online student. You're registering for the same classes. You are doing through the same admission requirements. All of the programs are exactly the same. The only difference is you're pursuing it from a distance. You're able to participate live via WebEx if you choose to, but don't need to. It is archived for viewing later in the evenings or on the weekends, whenever it fits best into your schedule. Homework is submitted electronically via email or upload to the course management system, and exams are done at proctored locations in your area. For instance, if you work near Los Angeles, then you would come to USC for your exams. Otherwise, our exam coordinator works with you to identify a proctored testing center near your home or office. It's a quick chart that just provides some of the similarities and differences between our on-campus and online students, but ultimately what we're showing here is that in terms of the admission requirements, the program requirements in terms of the units required to complete the program and the courses you're taking, those are all the same, and ultimately you are receiving the same diploma. It does not indicate online once you complete the program. The quick snapshot of one of our Dept Viterbi classrooms. So you can see that in the background of the picture, it's a standard classroom, something you're probably used to from your undergraduate experience. But in the back is where we have our camera operator and where we're able to remotely capture everything for remote delivery. A couple of quick things I just wanted to mention in terms of additional info for our Dept Viterbi, those of you that may be interested in Dept Viterbi or online delivery. The limited status option, I mentioned this earlier. This is how strong candidates are able to begin coursework before being formally admitted to a degree program. You're able to take a maximum of 12 units that can be applied toward a degree program once admitted, but it does not, limited status enrollment does not guarantee admission. You do need to qualify for limited status enrollment. That means you do have to have an undergraduate degree in engineering, math, or hard science with a cumulative undergraduate GPA of 3.0 or higher. If you meet those requirements, then you can get started as early as this summer 2019 semester. We provided a link there for further information. Another benefit for our Dept Viterbi students, those of you individuals that are receiving support from their company can actually defer the upfront payment of tuition until after the semester is over. If your company is paying 75 to 100% of your tuition in that semester, then you're eligible for this program. And again, a URL is provided for more information. In terms of our overview of tuition and fees, the following is our tuition and fee structure for the 2018-2019 academic year. Our current per unit cost is $2,005. Most computer science and informatics programs are going to be 4 units, which means your cost per course is going to be $8,020. Additional fees can apply, those differ depending on whether you're doing the program online or on campus, and you can find a breakdown of those fees by visiting the link provided. In terms of getting started, if you're interested in pursuing courses on campus, we encourage you to visit our campus, to take a tour, come to one of our on-campus events, and also to get your application started as quickly as possible. And then for those of you interested in taking classes online, you can begin classes as a limited status student this summer, or begin your application and email us for information on how to apply for formal admission this fall. All right, so that wraps up the presentation for today and provides you with some information here on how to get in contact with us. I'm just looking over some of the questions that have been asked. My colleague, Erin Tanaka, who I forgot to mention was on this session as well, I know has been answering them for those more specific questions that have been coming in. Okay, I think that, you know what, in all honesty, I think we're good to go with the questions. I think all the questions have been answered that have come through. The only question I think I'll just address out loud is there was a specific question on just how you can kind of learn a little bit more about the individual programs in computer science and informatics, and Erin shared here, and I think you can all see that in the Q&A, that you can visit the schedule of classes to get an idea about that. So please, yes.
Yeah, for the informatics program, there's also a web page for informatics. It's informatics.usc.edu. So, and that lists all the different degree programs and the set of requirements. Although I will say that I believe that the information I provided today about the Applied Data Science program is actually the most current on the slides we presented. I don't think it's been updated on the web page yet because it's the revision for next fall is still going through the final approval of the university, so we can't actually post it in there until it's been formally approved. But it's already gone through Viterbi, and so I expect that to be finalized shortly. And as soon as it is, then we'll update the web page as well there. But that's a good source for looking at informatics programs.
Perfect. And just as a note, I did put that in the chat section for those of you that can see it, so you can reference that at another point. Okay, well, I just want to thank you, Professor Knobloch and Professor Shahabi, for attending today's session and providing such wonderful information on the programs. Also to all of you that have listened to the program and absorbed all the information. I know there was a lot, so please don't hesitate to email or call us for more information. We're always happy to discuss any questions that you may have in more detail when we are able. So please, again, don't hesitate to give us a call or send an email to one of the emails provided here. And thank you again for taking time out of your day to learn a little bit more about our programs here at the USC Viterbi School of Engineering. Thanks and have a great day.